Hello guys, welcome to Electron and motion of electron in magnetic field. Now let's say we have a magnetic field like this where the velocity will go inwards. So that means the direction of magnetic field is this with the left hand. Now here let's say an electron is here and it enters into the electric field like this with initial velocity v, or just velocity v in this case. Now here we can use Fleming's left hand rule to find, well, the direction of Lorentz force. So here the velocity is going like this and here the magnetic field is inside like this. That means the Lorentz force acts this. But since this is an electron and this is actually for a proton, Fleming's left hand rule, the direction of Lorentz force is reversed, so it goes downwards. And here since velocity and magnetic field are both perpendicular, that means the motion of, well, electron in magnetic field is actually circular like this, and here the Lorentz force acts, well, perpendicular. This is the Lorentz force. I'll write FL. Now here, since the electron moves in a circular field, that means it has some centripetal force, and here this centripetal force is balanced by the Lorentz force. Now first let's find what Lorentz force is. Now here Lorentz force is given by QVB sine theta, right? So in this case the Lorentz force is, well, charge is E, velocity is V, B, and this is sine 90 because here the angle between velocity and the magnetic field is 90 degrees. So sine 90 is just 1 here, and the magnetic field, sorry, the centripetal force is given by mv square by r. So these two are equal to each other. So that means that mv square by r is equals to evb. So here this and that cancels, right? Square and square. Thus the radius is equals to mv by be. This is the radius of the path of the circle made by electron in the magnetic field. And from here you can also get the time period of the electron. So the time period to which the time taken for it to complete one circle, because we have the angular velocity omega as v by r, and in this here we have v by r is equals to be by m. So this is equals to be by m, and also omega is equals to 2 pi by time period, right? So here this is equals to that. So time period, I'll write it right here, 2 pi by t is equals to be by m, where m is mass of electron, of course. So time period is equals to 2 pi m by be. And of course you can also find the frequency as well. And this is all for motion in magnetic field. There is nothing more. You only have to realize that electron goes in a circular field producing centripetal force, and this centripetal force balances the Lorentz force experienced by the electron. These two will be equal, hence you will get relation for velocity as well as radius as well as magnetic field. So you can calculate either of those, and the charge of electron is constant and also the mass of it is constant, and based on the numericals you will get either this or this, and the numerical will also sometimes ask you to find the time period of revolution or the frequency of revolution. So frequency is 1 by time period, right? So which is just equals to 1 by 2 pi be by m, and of course omega is equals to velocity by radius, which is equals to be by m. So that is all. If you have learned something new, please like and subscribe. Thank you.